This is an Excel tutorial for Chem 1B Lab, Experiment 2, the freezing point depression. So this is what your data hopefully should look like after you've worked it up. Notice that for this column here, this is my my number of readings, each of my readings that I take at a different time. Here in this column I've got time and temperature. So if you use the Pasco Explorer, you're going to get a lot of data points because it will collect temperature readings every half seconds. If you had to do it by hand, the recommended intervals were every 15 seconds if you did it by hand. But hopefully if you got it through Excel from the Pasco Explorer, you can import that data into Excel and you can get a lot more data points to make a nicer, prettier graph. So this blue line here represents the data once it's graphed. So this is as we follow temperature versus time. Now to find the freezing point depression, we have to find the tangent lines and where they intersect. So the first tangent line goes through the initial data point, so the flat part right at the beginning. And the second tangent line is going to be towards the end here. So this is what this green line represents. And where these two tangent lines intersect, that's the freezing point. So notice up here I've got tangent line 1. So these are the data associated with tangent line 1. Tangent line 2, so that's the second one in green. And then where they intersect is the freezing point. So let's get started. So if you import your data into Excel from the Pasco Explorer, you should get 3 columns. The number of readings, the time, and the temperature. Now if you did this by hand and you were having to do the time, if your first time is 0, then for your next time, if you hit the equal sign and then the first cell, so E1, and then we plus 15, this will add 15 to the previous cell. So if you highlight and then hover so you get that little plus sign appearing, and then left click and drag down, it will automatically add 15 to each one. So notice we've gone into increments of 0, 15, 30, 45, 60, and so on. Now let's say you've only collected data points up until time 330 seconds. If you want, you can highlight the rest and simply delete it. Okay, so that's in case you have to do your readings by hand every 15 seconds. But I'm going to work up my data assuming that we can download the data from the Pasco Explorer. Okay, so if you highlight the 2 columns by left clicking and dragging over, we're going to insert a chart. So insert tab. We want to do a scatter plot. Left click on that. And rather than a dot for every data point, we've got so many data points so close together that they'll start to overlap with each other and it's hard to see our lines. So we want to check the smooth line. Okay, so there's our plot. I'm going to delete this legend because we're only going to put one graph on each chart. Now if it doesn't automatically come up with a chart title, you can go to Layout, insert Chart Title, and go above the chart. So we're going to call this Experiment 2. And this will be trial number C2. So I'm just using the C to represent the unknowns. This is the third type, and 2 means that this is my second trial of doing this data. So I'm also going to just make sure it's clear to me, unknown mixture. Okay, now we need to add in our axis titles. So let's do the primary vertical axis first. I'm going to select the rotated title. And I'm going to type in temperature. I'm going to separate that with a comma and then put a C so that we know that's in units of Celsius. Now we need to do our horizontal title. So we're going to select the title below the axis. And I can type in time, and we are doing this in units of seconds. So there's the main part of our graph. So this is what our data looks like as we follow the temperature versus time. Now we need to add in a tangent line for the first part and the second part. So let's do the first part. Okay, I'm going to give me a title up at the top just so I know what's going on. So tangent line 1, and I need to find the slope of that tangent line. So I'm going to label this M1, M meaning the slope and 1 referring to tangent line 1. Now I also need to find the y-intercept of that tangent line. So that I'm going to say B for represents intercept, 1 meaning tangent 1. Okay, so remember to do the slope, we click the equal sign, type slope, open up our parentheses, and we're going to select our y values. So our y is our temperature, and notice that we only need this portion of the graph. So we'll start at the beginning, and we'll maybe say go to about a temperature of 9. So start at the beginning, select down, and then we'll click a comma to separate that. Now we need to select the x values. So I'm going to select the x values. So I need to collect the same number in my box. Now close my parentheses and then click enter. So that's my slope for the first part. So I'm also going to highlight that. I'm going to copy this over, copy and paste, and it shouldn't have done that. Control Z fixes everything, right? So I'm just going to copy and paste this way. So notice it took the slope and it changed my columns from D2 and from C to D and B to C. So I'd like to go ahead. I'm going to change slope into intercept. And now my first one, my intercept should be my y, so my temperature. So I'm going to change these D's to C's. And then my x's were column B, so I'm just going to highlight this over and change that to B. Change that to B. So notice this is my y-intercept values. So my y columns from here to here, and my B. So I'm going to hit enter. And it looks like everything's going okay. So there's my first tangent line. Now we've got to do it for the second tangent line. So tangent line 2, and that's slope M2. And over here, y-intercept, this will be B2. Now when we collect the data for the slope, we only need this portion of the data, so I'm looking for the flat part of the line through here. So I'm going to say maybe we should start collecting the data maybe about 160 or so. It's kind of flat from this region from about 160 seconds down to 300. So that's, you notice that again is kind of arbitrary too. It doesn't have to be exact. So equal slope, open my parentheses, and I need to do my known y's. So my y's are my temperature, so I'm just going to scroll down until I start finding my time 150 in my B column. but I've still got to select this other column here. So notice we've collected lots and lots of data. Okay, I'm going to click and drag. Until I get the very last data point. Now I need to put a comma to separate. Now I need the x values. And since the x values in the column just one over, rather than highlighting it again, I'm going to save myself some time. So I'm going to just type in B303 colon B609. And I close my parentheses and click enter. Okay, so I should be back at the top. So everything's looking so far so good. Now my y-intercept, I'm just going to copy and paste this over. Okay, so rather than slope, I want intercept. And remember, because when I copied it over, it's going to shift all my letters for my columns over. But I need to change my D's back to C's and my C's back to B's. Okay, now I can click enter. Okay, so those are my slopes and intercepts for my two tangent lines. Now what I'd like to do is create the tangent lines on my graph. So I'm going to put in x values and then y values. So I want, for my first tangent line, we can start at x equals 0. So if y equals mx plus b, we can say, let's see, oops, I'm going to start at 0. So now for my y, so y equals my slope, so that's my m, times my x plus b, so my y-intercept right there. Now I can click enter. Now I want to do the same thing for another point. So maybe let's say 9 here. Let's see, that's probably about maybe a little further on. Let's go ahead and, because we want to past where it's going to intersect. So let's try maybe 60. So if, okay. So we're going to try 60. I'm going to say equals. So y equals mx plus b again. So my slope times my x plus my b. And that looks pretty good to me. So I'm going to add this data point to my graph. So I'm going to right click on my graph. I'm going to say select data, and I want to add a series. So my x values for this series, I'm going to click on this area, and this way I can just highlight my x values. And this will get me to return to that. Now I click on here so I can go to the chart to select my y values, here to here, and this will return me back. And notice how it's got my inserted in my line. So I'm going to say that's okay. And I don't need a series name. Okay, we're going to have to insert some more series for the next one, but let's go ahead and close this out. Oops, I didn't mean to cancel. Control Z. Oops. Well, I may have to do that again. Let's go ahead and create my lines for the second tangent line. So I'm just going to copy and paste these down. So Control C copies, and then Control V to paste. And so for the second tangent line, let's see, we'll need to choose X values. Let's say maybe about, we'll go from 0 to maybe 300. 0 to 300. So 300 was my last data point, and then 0 gets me all the way to here, so that we should definitely get an intersection. So now I've got to calculate those y values, what they would be if I had those x values. So y equals mx plus b, so equals my slope, m, times my x value, close my parenthesis, plus my y-intercept, and then click enter. Do the same thing for the next one. So equals slope times my x, close parentheses, plus my y-intercept, click enter. So it looks good to me. Okay, so now let's add those lines back in. So hover over your graph, right click, select data. Now we're going to add series. So we're going to add. Okay, so I need to select my x values. So there's one of my x values. Click on this to return me to there. And I need to get my y series. So I click on this so I can highlight the values directly in my graph. And I click back to return. And so I say that's okay because that looks good. Now I want to add another. So we don't need a series name again. We need to add another X series though. So this lets me select it from my graph. There's my X values, return, and my Y value series. And there we go. Return and select OK. And then close. There we go. So we're almost in the home stretch. So now what we need to do is take those two lines, solve them for x, and then set those two x's equal to each other. That way they cancel out. Then we're going to solve for y. Okay, so hopefully in class you should have seen how we solve for those two equations to get what we need. So I'm just going to paste what we did in class, or what we're going to do in class. So when we solve and we get what y equals to, b1, remember, is our y-intercept for the first tangent line. m2 is our slope for the second tangent line. So right here I'm going to calculate what my freezing point is. So freezing point, give me a label so I know what I'm doing. So I'm going to set in an equal signs, and I'm going to put in two parentheses so I don't get myself confused. I'm going to click on my B1 value times my M2 value, so find that down here. Close my parentheses. Now I'm going to subtract my B2 value right there. And I probably should have put in a parentheses. So I'm going to go back and parentheses, then my B2. Okay. Times my M1. So my M1 is right there. Close my parentheses. Close the second parentheses. Now I need to divide that all by M2 minus M1. So I'm going to put in, open up a new parentheses, highlight my M2 value, and subtract my M1 value right there. Close my parentheses and select and hit enter, and I've got my freezing point. Woohoo! That was a lot of work to get that, wasn't it? So I'm going to change the format on this so that it's a little more reasonable with Sig Fig. So my format cell, and I'm going to change that to number, and I only want to see one decimal place. So click OK, and I get a freezing point of 5.2. So notice that my freezing point is slightly different than what was on my first spreadsheet. So here I calculated 5.2. The first one I calculated 5.0. This is still within the error of my experiment. So remember, we have plus or minus in that last decimal place. So we're okay there. And part of that is going to be where you choose to make your tangent and where you choose to put in your tangent lines. So if you've got questions, please let me know. And remember, you can always fast forward, stop, and rewind just to kind of see what I did. And you'll have to do this for all 6 graphs. Take care.